We will continue our discussion of standard deviation, and we will revisit it to help you get a little better understanding of what the standard deviation actually is. The standard deviation, as we've described it, is the average distance of the data from the mean. That means that if you take a data set, you add them all together, you get a mean, which is the average, and then you look at how far they differ from the average and average the distance from the mean. That is the standard deviation. And the variance is the square of the standard deviation. Now, we're going to revisit these concepts and help you begin to get a statistical understanding of what the standard deviation does for us. Because the standard deviation tells us something about the scatter of the data set, whether they are close to the mean or whether they are scattered out from the mean. In statistics, many times you will see this curve. This is called a bell curve. And you will come to understand this curve as we go deeper and deeper into central tendency and we look at probability theories and those type things. But the standard deviation is the average distance of the data from the mean. So if we have a bunch of data, then we have a mean. And look at this graph pretty closely. This graph tells you in the bell curve that most of the data are very close to the mean, and that the further you get from the mean, the less data that there are. Now, we have these little data points. Here's a datum, here's a datum, here's a datum, and they constitute the data for whatever we're looking at. We know that it is a population because we have the letter mu. Now, this data right here is this far from the mean. This data out here is that far from the mean, and so forth. Each of these datum have a distance from the mean. Now, if we want to know what the standard deviation is, then all we have to do is add up all of these distances and find their average. The averages of these distances is the standard deviation. Now, lest you panic, keep in mind that what we're going to do to start with is we're going to use Excel. We're going to put in a group of data points, and we're going to add up those data points, and it will give us the average, and it will give us the standard deviation by pushing a button. Very clever. You're not going to have to do it by hand. Now, remember the symbols for population and sample. When we have a population, and that's represented by this circle, mu is the mean of the population, sigma is the standard deviation, and sigma square is the variance. To get the variance, you just square the standard deviation. And I remind you that the variance comes from a time before the advent of calculators, when it was much easier to just not take a square root. But now, it's so easy to take a square root that generally we talk about mean and standard deviation. You may hear somebody say the variance in the data set. All they're talking about is the distance of the data from the mean, and it's squared. So the population is mu and sigma squared. If we take a sample of the population, represented by this little maroon circle, then the sample has x bar, which stands for the mean of the sample, s, which stands for the standard deviation of the sample, and s squared, which stands for the variance of the sample. Now, I will remind you why we take a sample. Many times we have a population that it's so large we don't know about it. So what we do is we take a sample, and based on the sample, we describe the sample, and then once we describe the sample, we can use those descriptive statistics to infer about the population. So here you see descriptive statistics and inferential statistics. You're going to get into this. It's really cool. Now, I do want to calm you down. How much major mathematics have you done to this point? No, you're learning terms and definitions. You'll do a little stuff, but what we will do, we will use software, we will use spreadsheets, all sorts of things to help us and make it easier. Now, please forgive my lisp again. I've had major dental surgery. Wednesday, I have a full set of crowns put in. Today, I had 7 root canals, and a whole lot of other stuff done besides laser cutting of my gums to get ready for the bridge that they're going to put in. So just be patient with me. So we have a population, which is mu and sigma squared. We have a sample, which is x bar, s, and s squared. We take a sample, we describe it, and then we can infer about the population. The standard deviation, again, is the average distance of the data for the mean. And the cow said moo, moo, moo. And the cow said moo. You didn't know cows were doing statistics, did you? Now, what I want you to do is keep climbing the ladder. You got this. This is going to be enjoyable. You're going to understand this. You're going to be able to use this. You're going to be able to walk with this. So enjoy the journey together.